So again, take a look at quiz 9.4. Try to figure out what kind of problem you're working with. What kind of problem is this problem? What kind of problem is this? Okay, so what kind of problem is this? First of all, is it a proportion or is it a mean problem?
Mean.
So how do you know it's a mean?
Data.
Yeah, because your data, a list of data is given, right? Whenever your data is numbers, it's a mean. For a proportion, your data would be yeses and nos. Everybody remember this? Okay, good. Second question is it a confidence interval or a hypothesis test?
Hypothesis.
Hypothesis test, how do you know?
Because it says, can it be concluded?
Yeah, concluded. Yep, absolutely, absolutely. Concluded. There's a question. Does anybody see the word estimate there? Does someone see estimate?
No.
No. A confidence interval will always say estimate or confidence interval. Does that make sense? Confidence interval is a synonym for estimate or estimate. If it has one of those two words in it, or phrases, confidence interval or estimate, then it's a confidence interval. If it doesn't, it's a hypothesis test. Great. So we know it's a hypothesis test. We know it's a mean. How many samples do I have?
One.
Is there one sample or two samples?
Two samples.
How many groups do I have?
Two.
Two. I have the 3 years ago group and I have the today group. Does everyone see that? There are two different groups. Okay, so it's two samples. It's a mean. It's a hypothesis test. So it can either be dependent or independent. They are very different. If you do the wrong one on the wrong one, vice versa, you'll lose 7 points on the exam because it's important to see the difference between them. So which one is this? Is it independent or dependent? Is it two separate groups or are the two groups connected to each other?
They're connected.
How do you know they're connected?
It's the same bank.
It's the same bank.
Yeah.
Does everyone follow me? Or follow what they're saying? It's the same bank 3 years ago and today. Same bank, same bank, same bank. Good? So these two are matched up in pairs. Right? It's not just one group and then a separate group. They're matched up. I have to give you the data, and the data has to be matched up in these pairs like this. And it'll be matched up in pairs like this, or matched up in pairs like this on your homework. It might be two columns instead of two rows, but they'll be matched up.
But it's to do the problem is the same.
Yep.
Okay. Horizontal or vertical.
Horizontal or vertical.
Okay.
What you do is you subtract them, and then it's no longer two samples. It's really one sample of the differences. So you treat it like one sample with a goal of 0. Your mu naught would be 0. Does that sort of make sense?
I'm sorry, you said that this was dependent.
Dependent. This one's dependent. So you're going to put this one into, I would suggest you put this one into list 2, this first group. Put the second group into list 3. And then in list 1, you do L1, L2 minus L3 to find your differences. Folks, remember how we did that last time? So again, stat edit, and put this group into list 2, and put this group into list 3, and then in L1, go up to the top where actually on the L1, and you do L2 minus L3, hit enter, and it'll subtract them for you and put that into list 1. And then it's just a one sample t-test. It's just a regular t-test on your differences. So that is what I would recommend that you do. Okay. And this quiz problem, the problem 1 is just like any other hypothesis test. The only difference is step 1 and step 3. Those are the only differences. Right? So you're going to have to subtract off the two lists and make them into one list of differences. Then it's basically a one sample t-test with mu naught as 0. Right? Your goal is 0. Your differences should be 0. So again, today we're reviewing 9.4 to make sure people have that down, because 9.4 is really fairly easy, but it has a few odd pieces that you have to do to it. And more importantly, you have to be identified as being dependent, which is that tough part. So we're going to review that a little bit, and then we're going to kind of start in on our review of chapters 7 through 9, which will continue next class. Today you have due 9195 is due today. On Wednesday, you have 9.3 due, and also you can turn in lab 8, your hypothesis test up until Wednesday, late for full credit. On Friday, you have 9.4 homework due. Please get that done. It's short. It's not super long, but you need to get some practice, on that one before the exam, because it's different from 9.3. So you need to kind of get some practice doing both of those. The exam's going to be a week from today, on Monday, May 1st. I'll do a review session for you folks this Thursday in here from 6:20 to 7:30. And that's just going to be basically more review or answering questions about stuff questions you have, pretty much. Also want to point out we have the market coming up. That is tomorrow. And it's going to be 12 to 3. Usually they kind of run out of stuff around 1:30 though, so try to get in there early if you want things. It's basically, you get this giant box of food and stuff. It's great. It's open to anybody in the community, any families, not just LPC students, but anyone. It's going to be, they're doing it in the courtyard of the 1600 building, so that's kind of the next parking lot over, kind of the administration building right in that kind of main area right there. And then they're also going to have one on May 23rd as well. So that'll be in the next one. So let people know if there's anybody who could use that. Great. And you don't have to be, it's for anybody. It's not just people who really need a lot of food, but just, if you're if you're a student and you could use some food, totally, you know what I mean? It's there for everyone. All right. Exam is going to be Monday, May 1st at 5 o'clock. It's going to cover chapters. Why am I reading this? Justin, go ahead and read for me.
Monday, May 1st at 5 p.m. or Tuesday, May 2nd at 1:30 or 4 o'clock. Exam 3 will cover chapter 7, 8, and 9. The study guide is in Canvas under study guides. You will also need your magic formula sheet, half page of handwritten notes, TI calculator, and optional scratch paper / T-TAC table.
T-table, yeah. If you want the T-table, you can bring the T-table if you like. Don't forget, there's 2 fixes to the study guides, number 19 and 20. We went over those last class, so check with your neighbors about those. And I believe I have put in the corrected, updated version into Canvas, so you can always check there as well.
Is the key on Canvas?
The answer key, I believe, is on Canvas. It should be, yes. Let me know if there's anything in there that isn't complete. All right. And then don't forget, we talked about expert students last time, right? How looking at expert students and what they do, they look at how things are connected more and try to understand the problem, not just how do I blindly do these steps. They also tend to, have study groups. That's something you should practice doing now. That's critical for your success in the future. And also that curve of forgetting, right? Study a little bit along the way, not just at the end. Right? Study as you're learning it throughout. Review it the next day or a couple of days later, and think about how you learn best. All those sorts of tips. And then we also talked about math anxiety last time, right? So, just do the best you can. Right? If all you know is 20%, then that's fine. Just show me your 20%. Right? If all you, or maybe ideally 50%. All you know is 50%, that's okay. Don't freak out about what you don't know. Just show me what you do know. Show me that 50%, because that 50% is way better than a 0. So people who freak out, turn in a blank sheet because they freaked out. That doesn't show me what they know, right? You don't have to know everything. It's okay. Just study the best you can, prepare the best you can, and just show me what you do know. Okay, everybody all good with that part? So, don't in life, don't put a lot of pressure on yourself to have to live up to something. Do the best you can, and that's good enough. That's how life works. All right. So just as a reminder, 9.3 with 2 means are independent. That means we have a random group that we have sampled, Like say, I want to know if my gas additive gives you better gas mileage. So I take a random sample of people who are using the gas additive and a random sample of people who are not using the gas additive. Two independent samples. They're not tied to each other in any way. They're just one group randomly, another group randomly, and I'm going to compare the two groups. This is independent. They have nothing to do with each other. There's no data being shown, right? Because if they're dependent, I have to show you the data, and they have to be matched up in pairs. I can't just give you means and standard deviations. So this is independent. So H0 is always going to be that mu1 equals mu2, and the H1 will be that they differ in some way. This is when they're independent. mu1, mu2. Incidentally, please note that that means also that if I subtracted them, if they're equal, if I subtract them, they would equal 0. Does everyone see that part there? So their differences is 0. That's where this mu d comes from that we'll see throughout. It's actually true for any of the two samples, but we use that specifically in the dependent. For this one, you use this two-sample t-test. Right, with x bar 1, s1, n1, x bar 2, s2, n2, whatever your h1 is, symbol, greater than, less than, not equal to, and then you leave pooled as no. That's for two samples that are independent. If they're dependent, that's different. That's when they're matched up. How do I tell? Because they're matched up in pairs like this. They go together. So the first group, presidents, but the second group has to connect to the first group. I can't just grab Kennedy and any opponent. I have to grab Kennedy's opponent specifically, right? And the nice thing about that is what we do is we take these, we subtract them, -12, 8, 0, 1, and then we basically just ignore these two and we just do a one-sample t-test just on the differences. So now we've taken two samples and made them into one sample. So in this case, we would do a one-sample t-test just on the differences. And again, just as notation, the little d's is like our little x's, only the differences for each pair. Mu d is the theoretical mean of all of them. X bar d is the, if I took that sample and averaged those differences, what I'd get. SD is their standard deviation, and n is the number of pairs I have, or the number of little d's I have. Same thing. And here's where the difference comes. Here we have mu d is equal to 0. Remember, mu d is mu1 minus mu2. So this mu d is equal to mu1 minus mu2. But because we no longer have two samples, we made them into one by subtracting them, it's really just mu d. That's why I kind of want you to get in the habit of writing just mu d in there, not mu1 minus mu2, because that should be your clue that, oh, one sample t-test, not two samples. Right? Because I've subtracted the first group from this, taken the first group, subtracted the second group to get my d's. Now it's just one sample I have left, mu d. So that's why we have mu d, and what should they be? u1 minus mu2 should be 0. Remember, we looked at that just a second ago. We're saying that if mu1 is equal to mu2, then when you subtract them, you should get 0. Right? If two things are the same, subtract them, you should get 0. So that's why it's always equal to 0. Only in the two sample. This 0 is only true when you have two samples, because you're looking at the differences between them. If you have one sample, it's going to be a number, right? 53.6 or some number. Don't start taking this 0 and putting it in everything. This is not true for one sample. It's only true for two samples, because two samples is the differences. Good? So that's been a common problem for people in the past, so I'll make sure that we're super clear on that. And then, obviously, mu d would H1 will be that it's greater than, less than, or not equal to 0. All right, so here's how you do it. You put group 1 into list 2, put the second group into list 3, and then you do L1 minus L2. In L1 you do, in L1 you put L2 minus L3. So I will show you my example. Stat edit. I will clear this. And I'm going to put in the heights of presidents. So those were 189, 173, 183, 180, 179. That's my first list. That comes from this top row there. Then I put the second row into list 2, 170, 185. 175, 180, 178. And then I double check to make sure my data is right, because if you mistype something, then you're going to have big trouble. Right, so double check, make sure your numbers are correct. And then we're going to go over to, so not here. Someone see where my cursor's below the L1? It's in L1, but it's not on the L1. I arrow up so that my cursor's on the L1 itself. And then I do L2, which is second 2. It gives me L2 minus second 3, which gives me L3. Hit enter, and then bam, there we have it. Then I'm going to do stat, test, t-test. Data, mu naught is 0, list 1, frequency 1, leave the frequency at 1, and then whatever your claim was. I always said that they are bigger, so greater than mu naught, calculate, and then you'll have your t-value and your p-value. Okay, so do you folks need another minute to finish yours? Or are you feeling pretty okay with all of that?
I'm ready.
Ready? Oh, sorry, what did you say? Good? Okay. All right. Should we go over somebody's, I'm going to pause it for a second in case people at home need a break. So the question was, should it be, okay, so 3 years ago, less 3 years ago. So you're saying that it should be
concluded that because it's saying, can it be concluded that the average in deposits for the bank was less
3 years ago
3 years ago than
it is today?
Yeah.
So 3
Would
years
it be
ago,
less than 3?
less than 3 years. So less 3 years ago. So today you have how much? $100. What did you have 3 years ago? $120. So less 3 years ago, when you had 120 than it is today. We're not saying you have $3 less than you had 3 years ago. We're saying the time frame 3 years ago compared to today. Do you see that? So the 3 years ago is your group.
It's your time frame.
It's your time frame, yeah. Does that make sense? Was less 3 years ago than it is today.
It's asking for the amount of the deposit, like in the deposit, but not like the time frame. So like the difference between the two values is what you're really looking for.
Yeah, there. I can see it now.
Yeah. Good, good. All right, great. So, so we're comparing your two groups, the group 3 years ago to the group today. We're making this one our group 1. Then we're saying that this one is less than today. So does that make sense? Everyone kind of following? We're saying that the first group is less than the second group, so we should be using less than. Okay, good, good. All right, Dia, go ahead and explain what you did.
Well, first from like step 1.
Mm-hmm.
Oh, okay. So first your mu d is set to 0 because it's like you want the h naught to be like when there's no change, and then your alternative hypothesis is when it's less than 0, and that would be your claim because that's what's said in the problem, and you want to support the claim. And then the second step is writing your alpha, which is 0.05, and then you use the t-test to test for like
Yep.
yeah. And then,
So I think what you did was you actually, looks like you manually subtracted all of them.
oh no, I put it in my calculator.
Okay.
I just wrote it down.
So she put it in her calculator and she wrote it down. Okay.
Yeah.
Good.
But I did the whole steps that you listed before in my calculator, and then I got my t value to equal negative 1.674, and then my PV value was 0.066, and then you set your p value to your alpha and you compare them, and my p value was greater than the alpha, so it ended up failing to reject H naught, and then my final hypothesis was there isn't enough evidence because I failed it, because I failed H naught, failed to reject it, to support the claim that the average deposits for the bank was less 3 years ago than today.
Good. So everyone kind of following? So hopefully this is all sort of sinking in and making sense for folks, because we've been doing hypothesis tests for a while now. So good. So again, failed to reject means there is not enough evidence. Yes?
I have a quick question. When you're doing dependent sample problems, is the difference, what is the difference mean? How do you say it? U difference?
UD.
It's always, you always put 0.
You always compare it to 0 because the difference should be what? If they're the same, what's their difference? What's the difference between them?
There's no difference.
There's no difference.
Yeah.
So if there's no difference, the difference should be 0.
Okay.
Because and that's only when you have 2 samples. When you have 2 samples, you're comparing them to each other. You're looking at the difference between them. The difference between them should be 0.
It means like there's no change.
Right.
There's no change.
No change. No change would mean
That's
0 change. So mu d would be 0. Right. 0 billions.
Oh, so if I just have the 0, then
0 billion. 0. And that does totally affect what you put into your test, right?
yeah.
It affects this number right there, and that makes a big change on how things go. Yeah, that's where we're going over this. And remember that 0 is only true for 2 samples. Don't use that 0 for other, for 1 sample t-tests. It's only when we have 2 samples that are dependent that we use that 0 there. Okay. Quiz problem number 2. Let's get a reader. Devin, go ahead.
What are the 2 possible results when you reject the null hypothesis from mean? Pick one. You want me to read all of them?
Well, what do you folks think? Okay, so read the first part for A, yeah.
Either your population is actually different from mu naught, or you randomly get a very likely result.
Okay, so if you reject the null hypothesis, the null hypothesis says, let's just be clear on what we're talking about here. The null hypothesis, let me draw my little picture, says that I am right here. I'm right at mu naught. If I reject the null hypothesis, where am I? Am I on the end or am I in the middle? What is that? Yep. So if I'm out here, I'll do it even, this is me. Does that make sense?
Yep.
So, I'll call it sample. That's probably more clear. So if I reject the null hypothesis, is that saying that I'm out there? Or is that saying that I'm like in here?
That you're out there?
But yeah, if I reject the null hypothesis, everybody on board? It says that I'm out there. So, if I'm out there, is my population different from the mean?
Yes.
Yes, I'm far away. Is that, or another possibility could be I randomly got a very likely result. Is that sample out there very likely?
No.
No. So it's not the first one. Is everybody on board?
No.
So it's true that I'm different from the mean, from mu naught, but that is not likely. So we want where I'm very different from the mean, from mu naught. So I do want to be different, but I'm or I'm unlikely. Is everyone kind of following that? So which one of those is that I'm different and I'm unlikely, or I'm unlikely?
C. Charlie.
Good, Charlie. Yeah, there you go. Perfect. Good, good. I am hopeful. Shauna, go ahead and read the next one.
What are two possible results when you reject the null hypotheses? Choose two.
Great. Go ahead and read the first one.
We do not have enough evidence to support or reject our claim.
Is that true, folks? If I reject null hypothesis, do I not have enough evidence?
We have enough evidence.
I do have enough evidence. So that's not correct. How about B then?
Yes.
Yes. Okay, read C for me, Shauna.
It is likely that the observed difference between my sample and mu naught or p naught is due to random chance.
If I reject the null hypothesis, is it likely that my difference is due to random chance?
No.
No. It's unlikely it's due to random chance. Does that sort of make sense? In other words, remember, my p-value is how likely my sample, or I should say, my sample differs from mu naught by random chance.
Or we have multiple choice on these, right?
Yes, absolutely. So it's not due to random chance if my, so instead it's likely that the observed difference to my sample and mu naught or p naught is real. There is a difference. Right. If you reject the null hypothesis, that means that what you're seeing in your sample versus mu naught, there probably is a real difference. It's not just random chance. Because again, random chance would be this step in here would be random chance. Does that make sense to folks?
Mm-hmm.
That's the random chance area. If you get something in there. If you get something way out here, that's not due to random chance. That's due to the fact that there really is a difference. Right, my proportion of red cards really isn't 50%. There really is a difference. Okay. Isaiah, go ahead and read.
What does a large p-value mean? Choose two.
Great, read the first one.
We do not have enough evidence to support / reject our claim.
What do you folks think? Large p-value? We do not have enough evidence to support our claim or reject our claim?
We do have enough.
Why don't you folks talk about this one for a minute? Talk through these ones for a minute. So we do not have enough evidence is correct. That's good. I think the tricky part is the second one, which again is something I just kind of went over. I've only gone over it a couple of times for today, briefly. So kind of want you folks to wrap your heads around that one and take a look.